The videos in this module focus on prediction modeling, where we will be introduced to several common modeling methods, and we will also cover methods and metrics for evaluating models. Typically, when we discuss the topic of prediction modeling, we are generally referring to the training and application of machine learning or statistical models to our data. When we talk about using models to analyze our data, the general goal is to identify and potentially examine the patterns and relationships that emerge within that data. These models typically fall into one of two categories: supervised learning and unsupervised learning models, although it is not uncommon to combine these two modeling approaches within a semi-supervised methodology. In this module, we will largely focus on supervised learning from a prediction modeling perspective. In supervised learning approaches, we have a target variable of interest, something that we typically want to predict, and have other variables that we can use toward this goal. We can use statistical and machine learning models to identify the relationships and patterns that exist between a set of variables and our target. In most contexts, this target variable, the thing that we want to predict, is referred to as the dependent variable or the label, while the others are referred to as independent variables, covariates, predictors, and more generally, features. In colloquial speech, independent variables, covariates, predictors, features, and variables are often all used interchangeably, despite subtle differences in some of their definitions, which will be revisited at the end of this video. Terms such as features or variables are usually used in a more generalized manner to refer to things that are being measured in our data, but this language may differ depending on your specific context and the audience that you are presenting to. And with these models, there are certain types of research questions that we can address. Prediction modeling, as the name suggests, can help us understand how well we can forecast or predict some future event. This could be something like examining how well we can predict a student's test scores, or how well students are likely to perform on the next quiz or at the end of the year. We can also build models to predict students' likelihood of attending college or their risk of dropping out of a course or out of school as a means of identifying students who are struggling. Or on a finer grained level, we can build models to predict whether students are likely to answer their next problem correctly as a measure of their knowledge. But we can also use prediction modeling to detect whether an event or some behavior has already occurred, or even whether it is currently occurring in real time. We may want to develop models that detect students who are struggling in order to direct help to those individuals. We can identify measures and behaviors that are otherwise difficult to measure, such as students' affect and emotion. From a measurement perspective, we can detect whether a student is exhibiting mastery of a concept, or in a post hoc manner, attempt to identify where a moment of learning might have happened. But beyond predicting or detecting a target outcome or measure, we sometimes care more about identifying features that are strong indicators of an outcome, so that maybe those features can act themselves like a low-fidelity indicator. So in other words, rather than training a model with the purpose of deploying it, we could use the model to learn what the strongest predictors of something like student dropout or college enrollment are, and simply monitor those measures. This is useful particularly in contexts where it may be infeasible or impractical to deploy and regularly update a prediction model. But of course, understanding feature importance can have a range of use cases, from better understanding relationships in your data to helping to guide iterative improvements to develop more accurate models. And speaking of understanding relationships, while some modeling techniques offer greater transparency and interpretability than others, we often want to use prediction modeling as a way of understanding the strength and directionality of correlations between our features and outcomes under certain conditions. If we want to measure the effect of a learning intervention, the impact that it has likely depends on how well students knew the topic before receiving that intervention. By holding a measure such as prior knowledge constant, effectively controlling for that variable, we can more accurately measure the relationship between our intervention and the outcome that we care about. Similarly, the interaction between variables might matter. Consider how something like the relationship between study time and test scores might be drastically impacted by the method that was used by the student to study. In practice, we often want to examine how two variables are correlated or even causally linked. It is important to emphasize, however, that prediction modeling as a methodology doesn't itself allow us to make causal claims without pairing it with other experimental or analytical design methods. So even if we identify a variable as predictive of another, it doesn't necessarily mean that the feature causes the other. But as described earlier, we do typically want to examine how multiple variables relate to a single target. In practice, especially within educational data, it is quite rare for two variables to share a relationship that is truly independent. It is much more commonly the case that variables are influenced by others in a myriad of ways. Supervised learning does allow us to examine individual relationships while controlling for other confounding variables that might otherwise introduce noise and confuse our understanding of that relationship. So to recap, prediction modeling typically follows a supervised or semi-supervised learning paradigm where we want to predict a dependent or target variable using a set of independent variables while controlling for confounding covariates and other predictors.